Welcome to a journey through the secrets of our solar system. From the blazing sun at its center to the icy edges beyond Neptune, the solar system is a cosmic neighborhood filled with wonders. In this video, we'll explore the planets, moons, and mysterious objects that orbit our star. Whether you're a space enthusiast or just curious about what lies beyond our world, get ready to uncover fascinating facts and hidden stories. Let's begin by understanding what makes our solar system unique and why it continues to captivate scientists and dreamers alike. The heart of the solar system lies the sun, a massive ball of burning gas that provides light and warmth to all the planets. The sun's gravity holds the solar system together, and its energy drives weather and climate on Earth. Scientists have studied the sun for centuries, but it still holds many mysteries, such as the secrets of its powerful solar flares and the true nature of its core. Without the sun, life as we know it would not exist. Let's take a closer look at this incredible star and its vital role in our cosmic neighborhood. Mercury is the smallest planet and the one closest to the sun. Despite its proximity, Mercury isn't the hottest planet, but it does experience extreme temperatures. Its surface is covered in craters, and it has almost no atmosphere to protect it from the sun's intense radiation. Mercury's days are scorching while its nights are freezing cold. Scientists are fascinated by its mysterious magnetic field and the presence of ice in its shadowed crater. Mercury's unique characteristics make it a planet full of surprises. Venus is often called Earth's twin because of its similar size and composition. However, Venus is shrouded in thick clouds of toxic gas, making its surface hotter than Mercury's. The planet's atmosphere is mostly carbon dioxide, creating a runaway greenhouse effect. Venus rotates in the opposite direction to most planets, and its surface is marked by volcanoes and vast plains. Despite its harsh environment, Venus continues to intrigue astronomers searching for clues about planetary evolution. Earth is the only planet known to support life. Its surface is covered with water, and its atmosphere is rich in oxygen and nitrogen. The planet's magnetic field protects us from harmful solar radiation, while its distance from the sun allows for a stable climate. Earth's diverse ecosystems and dynamic weather make it unique in the solar system. From lush forests to vast oceans, Earth's beauty and complexity are unmatched. Let's appreciate the wonders of our home planet as we continue our journey. Orbiting Earth is the Moon, our closest celestial neighbor. The Moon's gravitational pull causes tides in our oceans and has influenced life on Earth for billions of years. Its surface is marked by craters and ancient lava flows. The Moon has inspired myths, legends, and scientific exploration. In 1969, humans set foot on the Moon, marking a giant leap in space exploration. Today, scientists study the Moon for clues about the early solar system and the possibility of future lunar colonies. Mars, known as the Red Planet, has long captured human imagination. Its rusty surface, towering volcanoes, and deep canyons make it a fascinating world. Mars has seasons, polar ice caps, and signs that liquid water once flowed on its surface. Robotic missions have discovered evidence of ancient rivers and possible microbial life. Scientists are now planning future missions to send humans to Mars, hoping to unlock more secrets about its past and potential for life. Between Mars and Jupiter lies the asteroid belt, a vast region filled with rocky debris. These asteroids are remnants from the early solar system, offering clues about its formation. Some asteroids are small, while others, like Ceres, are large enough to be considered dwarf planets. Scientists study asteroids to learn about the building blocks of planets and the history of our solar system. Occasionally, asteroids cross paths with Earth, reminding us of the dynamic nature of space. Jupiter is the largest planet in the solar system, a true giant made mostly of gas. Its swirling clouds and iconic Great Red Spot are visible even through small telescopes. Jupiter's strong magnetic field and dozens of moons make it a miniature solar system of its own. The planet's immense gravity influences the orbits of other objects, helping to shape the solar system's structure. Jupiter's mysteries continue to inspire scientists and astronomers worldwide. Jupiter is orbited by more than 70 moons, each with its own unique features. The four largest, known as the Galilean moons, include Io, Europa, Ganymede, and Callisto. Io is the most volcanically active body in the solar system, while Europa may harbor a subsurface ocean. Ganymede is the largest moon, even bigger than Mercury. These moons are worlds in their own right, offering endless opportunities for discovery and exploration. Saturn is famous for its stunning rings, made of ice and rock particles. This gas giant is the second largest planet in the solar system and has a unique golden hue. Saturn's rings are divided into several sections, each with its own characteristics. The planet also has dozens of moons, including Titan, which has a thick atmosphere and lakes of liquid methane. Saturn's beauty and complexity make it a favorite target for telescopes and space missions. Rings of Saturn are one of the most recognizable features in the solar system. Composed of countless particles of ice and rock, they stretch for thousands of kilometers but are incredibly thin. Scientists believe the rings may be remnants of a shattered moon or comet. The structure and composition of the rings continue to puzzle astronomers, and ongoing missions aim to uncover their origins and fate. Titan is Saturn's largest moon and the second largest in the solar system. It has a thick, orange atmosphere and lakes of liquid methane and ethane. Titan's surface is shrouded in mystery, with rivers, dunes, and possible cryovolcanoes. Scientists are fascinated by Titan's potential for prebiotic chemistry, making it a prime target for future exploration. Studying Titan could help us understand the origins of life in the universe. Uranus stands out because it rotates on its side, making its seasons extreme and unusual. This ice giant has a pale blue color due to methane in its atmosphere. Uranus has faint rings and at least 27 moons. Its cold, windy atmosphere and unique tilt make it a fascinating subject for astronomers. Despite being discovered over 2 centuries ago, Uranus still holds many secrets waiting to be revealed. Neptune is the farthest planet from the Sun and is known for its deep blue color and fierce winds. This ice giant has the fastest winds in the solar system, reaching up to 2,100 kilometers per hour. Neptune's atmosphere is rich in hydrogen, helium, and methane. The planet has several faint rings and 14 known moons, including Triton, which orbits in the opposite direction to Neptune's rotation. Neptune's dynamic weather and mysterious interior continue to intrigue scientists. It's considered the ninth planet. Pluto is now classified as a dwarf planet. It resides in the Kuiper belt, a region filled with icy bodies beyond Neptune. Pluto has a thin atmosphere and a heart-shaped glacier on its surface. Its orbit is highly elliptical, sometimes bringing it closer to the Sun than Neptune. The New Horizons mission revealed Pluto's complex geology and active surface, challenging our understanding of small worlds. Beyond Neptune lies the Kuiper belt, a vast region of icy objects and dwarf planets. The Kuiper belt is home to Pluto, Eris, Haumea, and Makemake, among others. These distant worlds are remnants from the solar system's formation. Scientists study the Kuiper belt to learn about the early days of our cosmic neighborhood and the processes that shaped it. The Kuiper belt remains one of the least explored regions of the solar system. Far beyond the Kuiper belt lies the Oort Cloud, a hypothetical shell of icy bodies surrounding the solar system. The Oort Cloud is believed to be the source of long-period comets that occasionally visit the inner solar system. Although no spacecraft has reached the Oort Cloud, its existence is supported by observations of comet orbits. The Oort Cloud marks the boundary between our solar system and interstellar space. Comets are icy bodies that travel through the solar system on elongated orbits. When they approach the Sun, their ices vaporize, creating glowing tails that can stretch for millions of kilometers. Comets are ancient relics, preserving material from the early solar system. Famous comets like Halley's Comet have been observed for centuries, inspiring awe and curiosity. Studying comets helps scientists understand the origins of water and organic molecules on Earth. Meteoroids are small rocks or particles traveling through space. When they enter Earth's atmosphere and burn up, they become meteors, often seen as shooting stars. If a meteor survives its journey and lands on Earth, it is called a meteorite. These space rocks provide valuable information about the solar system's history. Some meteorites contain material older than Earth itself, offering a glimpse into the building blocks of planets. Solar system formed about 4.6 billion years ago from a giant cloud of gas and dust. Gravity caused the cloud to collapse, forming the Sun at its center. The remaining material flattened into a disk, where planets, moons, and other objects gradually took shape. This process, known as accretion, created the diverse worlds we see today. Studying the formation of the solar system helps us understand the origins of planets around other stars. Habitable zone, also known as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist. In our solar system, Earth is perfectly positioned within this zone, allowing life to thrive. Scientists search for habitable zones around other stars in the quest to find extraterrestrial life. Understanding the habitable zone is key to exploring the potential for life beyond our planet. Each planet in the solar system has a unique atmosphere, ranging from the thick clouds of Venus to the thin air of Mars. These atmospheres play a crucial role in shaping surface conditions and weather. For example, Jupiter's atmosphere is dominated by hydrogen and helium, while Earth supports life. Studying planetary atmospheres helps scientists understand climate, weather patterns, and the potential for habitability on other worlds. Many planets, including Earth, have magnetic fields that protect them from solar and cosmic radiation. These fields are generated by the movement of molten metal in planetary cores. Jupiter's magnetic field is the strongest, creating intense radiation belts. Magnetic fields influence auroras, protect atmospheres, and play a role in planetary evolution. Understanding these invisible shields is essential for studying the solar system's dynamics. Sun constantly emits a stream of charged particles known as the solar wind. This wind interacts with planetary magnetic fields, causing phenomena like auroras and geomagnetic storms. Space weather can affect satellites, power grids, and communication systems on Earth. Studying the solar wind helps scientists predict space weather and protect technology. The dynamic relationship between the Sun and its planets is a key aspect of solar system science. Gravity is the force that holds the solar system together. It keeps planets in orbit around the Sun and governs the motion of moons, asteroids, and comets. Gravity also shapes the structure of galaxies and the universe itself. Understanding gravity is fundamental to exploring the cosmos and unraveling the mysteries of planetary motion. From falling apples to orbiting planets, gravity is the invisible glue of the universe. While Saturn's rings are the most famous, other planets like Jupiter, Uranus, and Neptune also have ring systems. These rings are made of dust, ice, and rock and vary in size and brightness. Studying planetary rings helps scientists understand the processes that shape planetary systems. Each ring system is unique, offering clues about the history and evolution of the planets they surround. Solar system is home to more than 200 known moons, each with its own story. Some moons like Europa and Enceladus may have subsurface oceans, while others are covered in craters or volcanic activity. Moons can have atmospheres, magnetic fields, and even geysers. Exploring these diverse worlds helps scientists search for life and understand planetary systems beyond our own. Dwarf planets are small worlds that orbit the Sun but haven't cleared their orbits of other debris. Pluto, Eris, Haumea, and Makemake are some of the best-known examples. These objects challenge our definitions of planets and offer insights into the diversity of the solar system. Dwarf planets can have moons, atmospheres, and complex geology, making them fascinating targets for study. Trans-Neptunian objects, TNOs, are icy bodies that orbit the Sun beyond Neptune. These distant objects include Pluto, Eris, and many others in the Kuiper belt. TNOs are some of the most primitive objects in the solar system, preserving clues about its early history. Studying TNOs helps scientists understand the processes that shaped our cosmic neighborhood and the potential for discovering new worlds. Humans have sent spacecraft to every planet in the solar system, from the Mariner missions to the Voyager probes. These missions have revealed stunning images and groundbreaking discoveries. Robotic explorers like Curiosity and Perseverance continue to study Mars, while missions like Cassini and Juno have transformed our understanding of Saturn and Jupiter. The quest to explore the solar system is ongoing, with new missions planned for the future. Launched in 1977, Voyager 1 and Voyager 2 are two of the most successful space missions in history. These spacecraft have traveled beyond the outer planets, sending back invaluable data and images. Voyager 1 is now in interstellar space, the farthest human-made object from Earth. The Voyager missions have expanded our knowledge of the solar system and continue to inspire future generations of explorers. New Horizons was launched in 2006 to explore Pluto and the Kuiper belt. In 2015, it became the first spacecraft to fly by Pluto, revealing its complex surface and atmosphere. New Horizons continues its journey, studying other distant objects in the Kuiper belt. The mission has transformed our understanding of the outer solar system and the diversity of small worlds beyond Neptune. One of the most exciting questions in solar system exploration is whether life exists beyond Earth. Scientists search for signs of life on Mars, Europa, Enceladus, and other worlds with water or organic molecules. Missions are designed to detect biosignatures and study environments where life could thrive. The search for life drives innovation and inspires humanity to look beyond our home planet. While our solar system is unique, astronomers have discovered thousands of exoplanets orbiting other stars. Some of these worlds are similar to Earth, while others are gas giants or icy bodies. Studying exoplanets helps scientists understand how planetary systems form and evolve. The search for habitable exoplanets continues, raising the possibility of finding life elsewhere in the universe. Sun, like all stars, has a life cycle. It formed from a cloud of gas and dust, shines as a main sequence star, and will eventually expand into a red giant. In billions of years, the Sun will shed its outer layers, leaving behind a white dwarf. Understanding the Sun's life cycle helps scientists predict the future of our solar system and the fate of its planets. Solar eclipses occur when the Moon passes between Earth and the Sun, casting a shadow on our planet. These rare events have fascinated humans for millennia, inspiring myths and scientific study. Eclipses provide opportunities to study the Sun's corona and test theories of gravity. Observing a solar eclipse is a breathtaking experience, reminding us of the dynamic nature of our solar system. Auroras, also known as the northern and southern lights, are spectacular displays of color in the sky. They occur when charged particles from the Sun interact with Earth's magnetic field and atmosphere. Auroras are most common near the poles and have been observed on other planets as well. These natural light shows are a beautiful reminder of the connection between the Sun and our planet. As we explore the solar system, it's important to protect both Earth and other worlds from contamination. Planetary protection involves preventing the spread of Earth microbes to other planets and avoiding bringing back harmful materials. Strict protocols are followed during space missions to ensure the integrity of scientific research and the safety of our planet. Responsible exploration is key to preserving the solar system's secret. Future of solar system exploration is bright, with new missions planned to study the Moon, Mars, Europa, and beyond. Advances in technology will enable humans to travel farther and learn more about our cosmic neighborhood. International cooperation and private companies are playing an increasing role in space exploration. The quest to unlock the solar system's secrets continues, inspiring generations to reach for the stars. Space telescopes like Hubble and James Webb have revolutionized our understanding of the solar system and the universe. By observing in different wavelengths, these telescopes reveal details invisible from Earth's surface. They have captured stunning images of planets, moons, and distant galaxies. Space telescopes continue to push the boundaries of discovery, helping scientists answer fundamental questions about our place in the cosmos. Astrobiology is the study of life in the universe, including its origins, evolution, and distribution. Scientists search for life on other planets and moons, study extreme environments on Earth, and develop new technologies for detecting biosignatures. Astrobiology combines biology, chemistry, and astronomy to answer one of humanity's oldest questions: are we alone in the universe? Collisions between asteroids, comets, and planets have shaped the solar system's history. These impacts can create craters, trigger mass extinctions, and even deliver water and organic molecules to planets. Studying cosmic collisions helps scientists understand planetary evolution and assess the risks of future impacts on Earth. The scars of ancient collisions are visible on many worlds, telling the story of a dynamic and ever-changing solar system. Our solar system is just one of billions in the Milky Way galaxy. It orbits the galactic center, taking about 230 million years to complete one revolution. The solar system's location influences its exposure to cosmic events and interstellar material. Understanding our place in the galaxy helps scientists study the broader context of planetary systems and the potential for life elsewhere. Secrets of the solar system are vast and ever-evolving. From the fiery sun to the icy edges of the Oort Cloud, each discovery leads to new questions and deeper mysteries. As technology advances and exploration continues, humanity's understanding of our cosmic neighborhood will only grow. The solar system invites us to dream, explore, and seek answers to the biggest questions about our place in the universe. The journey is far from over. There are always more secrets waiting to be uncovered.